Okay. So, did you hear him? I think he used the word relativity. Anytime you hear somebody talk about relativity, probably think about Einstein, because Einstein came up with the, well, two things, general relativity and special relativity. Um, but Einstein predicted black holes before they were like in. And what else did Einstein do? He did a lot of neat things. But one of the things, you know how Hubble later saw that the universe is expanding because galaxies are all moving faster away from us the further they are from us, the expanding universe. Einstein actually calculated that, but he thought it was wrong, and so he kind of said, I don't know, he thought he was wrong, but he was really right. So Einstein, smart guy. So one of the things, when we talk about Einstein's relativity, okay, is we need to think of, and this kind of makes sense to me. You know, we think of space, you know, we're walking here in space, but actually there's a time component to me as I'm walking here. There's the space, physical space, and then there's the time, okay? And so according to Einstein, actually space and time are a fabric together. And space and time can be distorted by objects that sit on them. When I say objects that sit on them, I should have said objects that sit on the fabric of space and time. Doesn't this look like a sheet? Here you have a sheet and you have four people holding it at the four corners, and here you put a couple of objects here and the sheet kind of pulls in. Okay, that's the fabric of space-time. And we all make a little dent in the fabric of space and time. Okay, the more massive the object, the bigger the dent. So there are these curves, and that's not a small thing. Actually, these curves are important. We can see these curves in the fabric of space and time. These curves actually are what ultimately kind of give us, when an object orbits, like a planet orbits a star, it's because of these curves. I know it's kind of strange, but the star has made a dent in the fabric of space and time. Gravity can be explained by this space-time sort of being dented. So here's the deal then. If this is the fabric of space and time with nothing on it, the more massive, but more specifically, if you have an object, the denser the object, the bigger it's going to make, okay? The bigger sag it's going to make. So no object, an object with a particular amount of density makes that sag. If you go ahead, and I'll go back over here to our Christmas wrapping paper, okay, if you have basically taken an object and squished it down to overcome neutron degeneracy, you have made something that in the fabric of space and time makes a hole. And like Tina was asking, I can't really think of it as a well like it's being shown here, because that seems directional to me. I mean, it seems like if you go at it from over here, you know, so I think this needs to almost kind of be lifted from here and kind of make it multi-directional. You know, because if you approach a black hole from under here, it's still a black hole. Does that make sense? But I think the easiest way they know to kind of show literally a hole in the fabric of space and time is what's created, but it's not like a well like this. So we talked about escape velocity, and the reason they call it a black hole is because light from the surface of a black hole, when it tries to escape, and it's going as fast as anything can go. We're going to see Einstein said nothing can go faster than light. Okay. So that's why they call it a black hole, because not even light can escape. Okay, so if you fall within the event horizon of a black hole, then there's no getting out, kind of like I think the video was saying. And if you did fall into a black hole, kind of it's your matter, your protons and neutrons, your atoms would basically, instead of becoming neutron soup, become some more other exotic sort of icky soup, okay? Where this says you wouldn't be neutrons really. Basically, your particles would be very strange. They would have mass, your particles would have mass as you were chopped up or just liquefied, okay? Your atoms wouldn't be carbon, your atoms wouldn't be nitrogen or oxygen like they are now, hydrogen. They'd just be, but it would add mass to the black hole. And black holes do feed. Here in a minute, and let's see, it seems like the video might have talked about accretion disk, maybe, maybe not. We've talked about accretion disks tonight. We talked about an accretion disk around a white dwarf, an accretion disk around a neutron star. There is an accretion disk that can be formed around a black hole. Okay, same thing. So that singularity is kind of the black hole itself. So another video.